Hi, this is an equations video on absolute value equations. These are a bit different, these ones. Absolute values take anything that's negative and turning them into positives. In these equations, we're not sure whether sometimes we're not sure whether the section inside the absolute value signs are supposed to be positive and those absolute value signs don't make any difference, or if the section in between the absolute value signs is negative and turns them into a positive. It's a bit hard to tell. So what we have to do is to basically have two versions of these. One where the contents of the absolute value signs makes no difference, and one where the scenario is where the absolute value sign content was a negative that turned into a positive. So we have to consider two different cases in most of these. So what we do is we treat this first scenario as if the absolute value signs never existed, and we just solve it as if if we're able to disappear those absolute value signs. It's kind of like being in denial. We just work oblivious to the absolute value signs. So we just got that. We wrote it out without the absolute value signs. We'll get the letter on its own by doing the opposite to both sides of whatever we need to move there. X equals minus 1. Now we'll have a big OR here. Now, to take into account the situation or the scenario where the contents of the absolute value signs was negative but turned into a positive, this is the way we set it up. We set it up with x plus 5 equaling, and we make the opposite value of the right hand side. So that's how we take into account the scenario of the absolute value signs working and making a difference. So that's how we do it. We put a minus on the opposite side there. Okay, so then we just solve it. Minus 5, that'll cancel out. X equals, now this will be minus 9 here, minus 4 minus another 5. So we've got there, that's our final result there. X equals minus 1 or x equals minus 9. So we need two different ways, two different sections of our working in each of these. This one, let's ignore the absolute value sign and pretend it never existed for our first scenario. We'll move a minus 6 by plussing 6 both sides. Okay, that's a nice and straightforward one there. But here we have to take into account the fact that it could have been m minus 6 making a negative and then turning into a positive using the absolute value sign. The way we do that is to take the opposite of a 3 and process that. We'll add 6 to both sides. Cancel, cancel. M equals 3 there. So it's m equals 9 or 3. So we'll get two answers for most of these. Alright, let's ignore it for the first version. Good practice for your solving of equations anyway. We'll move a plus 4 by minusing 4 both sides, leaving us with 3a equals minus 2. We'll divide by 3, divide by 3. A equals minus 2/3. Or we will have 3a plus 4 equaling the opposite of that right hand side, minus 2. Okay, we didn't need that there. Let's minus 4 both sides. The steps are similar, we're just doing a different version, that's all. 3a equals minus 6. We'll divide by 3, divide by 3. A equals, now minus 6 divided by 3, a minus divided by a plus is a minus answer. So just where our answer is, we'll put a big OR between those two. Alright, two versions once again. One where we ignore the absolute value signs totally, and one where we put the opposite sign next to the right hand side. And again, 2y minus 7 equals 3, ignoring the absolute value sign. We'll plus 7 like we're normally solving equations. 2y equals 10. Let's divide by 2 to get y on its own. Y equals 5. Or let's process it with not ignoring the absolute value sign by putting a minus in on the right hand side, or taking the opposite of it anyway. If that was a minus number to begin with, taking the opposite of that would turn into a plus number. So let's plus 7, we get 2y equals 4. Let's divide by 2, we get y equals 2. And we'll put an or there and maybe underline it, or put a box around it. So y equals 5 or 2, depending on whether the absolute value sign hadn't made any difference or not. Okay, same thing here. We'll just see if we need to do anything fancy here. It usually works out to be pretty much the same as equal signs, but once again we'll process the whole thing as if the absolute value sign never existed. Minus 2 to start solving this. 5c is less than 10. Divide by 5, c equals, it's not equal, less than, c is less than 2. Or, now, here we've got 5c plus 2 is less than minus 12. Not going to make a huge difference, I don't think, but that's the way we set it up. 5c is less than minus 14 there. We'll have to be careful. Minus 12 minus another 2. Then we'll divide by 5, a lot of solving here. C is less than, we could just write that as minus 14 over 5, because that's what happens when, you can set it up as a fraction with the bottom dividing into the top there. And we'll make sure we put an or in between there, so that, because they're both equally valid answers there. So that's pretty interesting. And okay, so we've taken the normal system, and we've also processed it with a negative, or the opposite version of the right hand side so far. Let's keep going. This one might work out to be a bit trickier. Let's see. This first version is just 5 minus 3k is greater than minus 2. We would be moving that 5 first. It's a positive 5, so let's minus 5 both sides. Minus 3k is greater than minus 7. We're going to be dividing by minus 3 here. Now, if you were listening in the last video on inequations, you'll notice there's something special that we do when we divide or multiply by a negative, and that is to switch the sign around. From this time it's switching from greater than to less than, and a minus divided by a minus is a plus, so we get 7 over 3 there. So that's that special rule that we have to kick in there. We have to, that's why the inequation sign switched to the other direction. Or 5 minus 3k is greater than. Now we usually put a minus on the end of the that final term to make it into a minus, because it has been a plus in all our examples so far, but it's a minus now. So if we put a minus on a minus, it turns it into a positive 2. So we have actually affected that. We just sort of turned a negative into a positive and we still did the opposite of what it was, I suppose. Alright, let's minus 5 both sides. Divide by minus 3. We once again have to kick in that rule about switching the direction of the inequation sign. And that turns back into a less than as well. And minus 3 divided by minus 3 is just going to be 1. So we have an or in between there. So there are two possible answers there. K is less than 7 over 3 and less than 1 there. Alright, next one. Now, this is going to be a bit different here. We have absolute values on both of them. Now we can do a version whereby we ignore the absolute value sign. And you might think we have to do 4 versions of this, but not really. Okay, let's do a version where we're kind of thinking that they're both positive. So we'll just process that. We'll minus m, or minus 1m both sides there. We get 3m plus 4 equals 6. Let us minus 4 both sides. 3m equals 2. Divide by 3, divide by 3. M equals 2/3. Okay, now on this right hand side, I'm going to do a version whereby we keep one of them positive and the other one negative. That's in keeping with what we did in the other examples so far. We left the left hand side to be normal and the right hand side we made the opposite. So that's what we have to do. We have to do one that's totally normal, which we've done there, and we've got an answer there. Here we have to make one of them the opposite of what it was. So we'll keep that normal, and we'll put a minus on the last term here. That last term is actually the whole of the absolute value bit. So we've got 4m plus 4. Now we have to be really careful with this other side here. It's like we've got a minus 1. We're taking the opposite of this right hand side to get the negative version there. So we'll have to expand that and be careful with it. So we've got 4m plus 4 equals, we've got minus 1m. Minus 1 times plus 6 is minus 6. So we'll add 1m there. We'll get 5m plus 4 equals minus 6. We'll minus 4 both sides. 5m equals minus 10. We'll divide by 5. M equals minus 2. So we have m equals 2/3 or m equals minus 2. Okay, well, that was tricky, but so we did a version where we ignored the absolute value again, and we did a version with the left hand side normal, but the right hand side having a negative on it. Okay, quite a bit of a process there. I think we've got one more to try before we finish up on this one. Yes, we do. So in the same keeping as in the same sort of way as we did before, we'll have a version with no changes at all and ignoring the absolute value sign. So it seems wrong when you do that, but still. And we'll process that before we start. So we've got a minus h, or minus 1h both sides, which will be 4h. Minus 2 equals minus 6. Let's plus 2 both sides. Hopefully you get plenty of practice at these solving of equations so you're nice and quick. Minus 4, let's divide by 4. We get h equals minus 1. Now in our second version we'll keep this the same, so we'll have 5h minus 2 equals, and we'll have a minus in front of that whole section. So we'll probably be best to put a minus 1 in front of h minus 6. Multiplying something by minus 1 really turns it into the opposite of what it was. So let's process that and get a solution for that as well. Minus 1 times h, minus 1 times minus 6 is plus 6. Let's plus 1h. Get 6h minus 2 equals, that'll cancel out, 6 plus 2 both sides. 6h equals 8. Let's divide by 6, divide by 6. We get h equals 8 over 6, or that can simplify down to be 4 on 3. So we get h equals minus 1, or h equals 4 on 3. So we, when we've got absolute values on both sides, we do a version with no changes whatsoever, just ignoring them, and we do a version with a minus 1 in front of one of the brackets. We could have had it on the left hand side. It works a little bit better if you've got it on the right hand side. So on that right hand side we just write it out. We've got to be careful with the expansion though, because anytime we've got a minus 1 in front of a bracket we can easily get it wrong. But that's how we do it, and we always get we seem to always get two versions of the answers there for absolute values. So get used to doing a normal version and then a version where the the last term there, or the last chunk, has a minus in front of it, and just processing that. At least you get great practice at solving equations. Alright, so that's your absolute value type scenario there. Hope that helps. PeterBlakeMaths.com. See you next time.